Hi guys, welcome once again to the channel. Today we'll be going into the design proper. I want you to stay with me as we go into design to show you the secrets and how you can carry out your design from scratch to finish. Let's go. Run your Orion. Close it. Comes up here. You click on new project. Type in the name of the project. The name of the project may be the name of the client, okay? So I'm making use of master class. Space bar does not work in this aspect. So for you to space in this place, you make use of shift and minus. You hold shift and you hold minus key to have that arrow like that. Then you continue master class. You click OK. These are the codes that this software is compatible with or makes use of. So, and in this context, we are going to be making use of VS Code VS8110. You click the code you want to make use of, tell it to import. It opens. This is the sheet size. It's asking you what sheet size is it going to be using for this drawing. Select the biggest one. Actually, this area does not really matter because you can even work with outside the sheet. Okay, so you click OK. It opens. Now this is the sheet size we have chosen, 1005 by 1000. Okay, all right. Now we have to import our drawing from AutoCAD, where we'll save it as DSF. We have to bring it into this environment. So what do? We will go to this external reference drawing. Now this external reference drawing, most people get this through this file. Go to import models, to file import, they come here and get it. Now the only benefit is that if you are importing from Revit structure that is supported also with this software, you can go through this place and import it here. You can do your general arrangement and everything in that format and import it here. It's gonna work. Okay, so this is another reference drawing is already here on the toolbar, so we just make use of this. Once you have started, anything that comes up, pops up telling you save, just say yes, so I can be saving whatever thing you are doing. So we go to DSF because we want to import our drawing. Now this is where I saved my DSF drawing. I click OK, I click it and I click open. It's asking me the unit is going to be making use of. Of course, you know it's mm. We have mm, we have cm, we have meters. So in this part of the world, we make use of mm for our drawing. Some other persons, some other people from different places may make use of cm, mm or meters, but we make use of mm. So it's already on mm. I click OK. Now the drawing is already inside. You can see most times this drawing will be very small by the right hand side down here, this area. So for you to move it to where you want it to be, you click on move. Remember, this is the sheet size you have prepared. I can work on outside this sheet size. I can take my drawing outside here and it works. So let me take it outside here and show you how also. So I click on move, then my right mouse, my left mouse, I hold it down and I drag it to where I want it to be, and I leave it. It will come there. You can see that when it comes up again, close it. You can see that I've removed it from the sheet side, from the sheet. So these sheets don't really matter. Okay. Now this is my drawing. Now these are the setup, these are the tools that we're making use of. all these things, all this drawing and all these lines, they are inactive in this environment. They don't support all this our normal layer in AutoCAD. So we are to trace everything that has been done here with replacement of Orion properties. Is that all right? Now, Orion properties, the grid lines, the column, the walls, and everything will be replaced. But this is going to be as a guide to aid our work. Therefore, it's going to be more easy. We are not drawing from we are not just thinking what to draw. This is already what we have. It's just to trace it, and that is all. That is our modeling. Now, these are the tools we're making use of. This is object snap. This is undo. We have done something and you don't really want, maybe you delete it and you don't want to delete, you don't have mind of deleting, or you have done something that you're not supposed to do. Just undo it through this undo. This is undo. This is object snap or snap. Okay, the way it functions in AutoCAD, that is the way it functions here in the Orion environment. Now this is clear section. Clear section. Clear section. It means that is our escape. When you are working now, you pick you give a command and they are through with that command and they want it go to another command, or you want to clear it, you want to escape it, you use this clear section selection. Now this is pick, the same way it works in AutoCAD. Pick, the same way it works here. We're not going to be making use of this pick because there are not much thing for us to be doing with it. All right, this is axis. This axis is talking about these grid lines. This grid lines is the axis in this context. Now this is column, this is wall, this is beam, this is slab. We have two types of slab here. We have the solid slab and the rib slab. So this can design solid slab and you can use it to design rib slab. Okay, all right. This is our slab straight, that is our reinforcement. This is our dimension, to check dimension. This is our section. This is a slab load. These are the slab opening. These are plane definition. This load decomposition, building analysis. This column section, column B, and not the rest. So you can take time to really go through them. All right. So we'll start by clicking this one. Now the way these tools are being arranged here, that is the way you make use of them, especially from this place to this place, from this place to this place. You make use of them one after the other. After this, you come to this. You don't do this and jump to this. You don't finish with this and go to this. You don't finish with this and go to this. You finish with this, you come to this. You finish with this, you come to this. If you are not making use of this, you go to this. If you are making use of this, after this, you go to this. Is that all right? That is how we will be following our design sequence that way. All right. Now I come to axis. I click on axis. Okay. This is label here. It's telling me that a place I'm going to put next is going to be label A, but in most cases it labels the vertical numbers and the horizontal alphabets. Vertical, it labels vertical numbers and the horizontal alphabet. Okay, this is horizontal, right? This alphabet. Okay, let's just put, it can still number it for us. Okay, you can see it number it as 1. Why A it was, why A here. But if I still want it to be A, I just click A here. I just change it to be A and I update it. It's going to give me, because is what I impute is what that's what I get. Okay, and as I put A and it has given me, if I put the next one, it will continue A, B, C, D, just like that. If I put 1 and update it, it gives me 1. If I put 1 and I update, put 1 and I update, it gives me 1. And if I continue putting, it's going to, if I continue, it's going to be numbering 1, 2, 3, 4. Do you understand? Alright, let's move on. So I put here, I keep on inserting my axis. If you want your axis to be very straight, once you pick the first point, you hold your control key down, it will straighten it for you and leave it. Now most times when you are holding your control key and suddenly you leave it by force, it may bring this. Just be conscious of this box. This box may change and bring up another box, and once it brings up that other box, it is not going to insert anything at that moment. It's not going to insert another thing that moment. So what you need to do when it brings up that box and you insert, it didn't insert, you just come and click axis property there. There's where here you will see axis. Just click on that axis, it will come back to this normal box. You continue what you are doing. Please, you have to take note, because so many persons will encounter that and they will say that they have encountered issue. It's not an issue, okay? So that is it. Make sure you hold your control. Remember, you are replacing these grid lines. If you make mistake, it's going to affect your dimensioning and it may affect the building you are really designing. So that is why we make everything accurate. We are only tracing. Please take note of these lines. They must not be double. It must be exactly. Is that alright? Since I'm through with this area now, this is 10. Okay, and I go to horizontal. I didn't change anything, no, just be watching. Alright, it's going to number by itself. It will know that I've gone to horizontal. You can see it give me A. Alright, I continue. To give me B, to give me C, and so forth and so on. For you to be sure, you may not be picking it from outside exactly. You can take your cursor inside a little, so that you will be seeing the remaining one, if it's actually at the middle or not. Okay, yes, you can pick it from like this. You can do it like this, so that the remaining will show, this one will show, so you can use it to trace if it's at the middle or not middle. Thank you. All right, we are through with the axis. Now the next thing we need to go into now is our columns. Okay, all right, I'll click on the column. I will change this is the size of the column I want to put, 225 by 225. 225 by 22. That's the size of the column. Now I'll come here, insertion option. I click it. These are different patterns on how they put column. You can start to put a column inside your grid. You can start to put column like this at the edges. This will be like this. That is, this is the grid line. This is the grid line. Column will be at the edge, a 90-degree angle. You can start to put it this way, but you know, in this our pattern of design, we make use of centricity. You have to make it to be centered, aligning with the blocks, column together with blocks and everything. At the end of the day, you should not be able to identify where column and where block is. We make use of it, so it is buried. That is to say that this is how we work. So we select this middle, right? Now we come. We begin to put our columns, but this is not as complex, too much complex. But you may have complex jobs. If you have complex jobs, it will warrant you to bring up the interface of the two to enable you to have clearer view. You see it now? You can actually put the two together so that it will be easy for you to identify it where the columns are. Now with this, now I can just be looking here and be putting my columns. I put column because there's column there. See, I put here, put here. Now note, columns does not enter where there is no cross line. Columns enters only where you have cross lines. The center, that is where it enters. It can enter here, though this is a grid line can enter. Except I cross line here for column can enter, because that is what we selected. Alright. So I continue. As the engineer, you are the one to determine where columns will be in a drawing. You are the one, that is why you are doing the design. You are the one that will actually tell them this place is where column will be, this place is not where column will be. Is that okay? I don't want to put column here because, you know, in our general arrangement I said something. There are places we're introducing beams, so I want to put column here to take care of this beam that will be coming here on top. Please take note. Now this span between here and here, this beam, this column is enough. Alright, and I'm going to put column here also, so this beam can be able to carry this. Of course this doesn't have any much load, so it's not a must that your columns must be at the junction. Take note, you must understand general arrangement and the reason why it is so. Okay, for those of us who have not been conversant with manual design, do well to know manual design, because if you don't know it, you will not be able to know what you are doing. This is software. It's only what you put in, what you get is garbage in and garbage out. Okay, so remember, following the general arrangement I've done. Remember, this is cantilever. When we go up, this wall will be pushed out to this place and this column will come here. Don't forget. So make sure that you are conversant with the general arrangements we have done to enable us move faster. Alright, now you are through with this. I want to tell you that you have gone some extent. Okay, now this is normal conventional columns that we use. Now what if you are given a school to design and the school is having projection of columns by the side? Maybe columns is 450, that means it will project outside here by 450, project up here by 450, project down by 450, by 225. That means the column is 450. How will you do such thing? How will you do it? Talking about columns now. All right, I'm going to come back to that. Okay, let me just quickly say that. Now, when you have a column, let's assume, I'm assuming now, okay, this, let me make this to be 400, let me make this column to be 450 by 450 by 225, and remember is eccentricity. Now the column is like this, and you are to bring this column out. This place has to match with this place, so 225 should be from here to here, the remaining other 225 should be from here to here. How do you do it? How do you do it? Remember, any method you are using to do it must be an accepted method that will be recognized when you run your analysis. So in that case, how do you do it so that you will have your projection? It is very, very important you understand what you are doing. Okay, all right, in this context, what you need to do, highlight this column. The eccentricity will no more be the same. Highlight the column as it is like this. Go to your E1, go to your E1, which is this, make it to be minus 112.5, and put this one to be 0. Sorry, make this place 150, make this place 112.5. You update it. Okay, this one go the other way around. Okay, make it 337.5 and make here 112.5. You update it. Okay, you must take note of these things. How did I arrive at this? All right, the center of this 225 will be this way, 225 will be this way, right? Okay, now this is 225 here, this is 225 here. Is no more centralized. This area is harmony now, this area is harmony now. Now from here to here is 225. Is that all right? 450 minus from here to here is 225. From this here to here is 112.5. Now 112, 450 minus 112.5. What will you have at this side? That is 337.5. If you add 337.5 plus 112.5, it will give you 450. The centricity has changed. That is what I've done now. Please take note of this. You just go straight and just as very, very important. Take note of this. Now, not only this. Now, let's take another example. Another case. Now let's make this one to be 225 by 450. Let's make it 225 by 450. You update. Now see the way it is. 225 by 450. You can see this place is 112.5. 112.5. This is 225 inside this wall. We want to shift this 112.5 outside to start from here, so that we will have the remaining here. How do we do it? You must take note of all these things. Write them down. Now when I come here to change it, I will put my E to be 112.5. I update it. Now let's see what happens. 337.5. Let's see what it will give us. 112.5. This is 450. This is 450. This will give us 337.5. Then the upper one's supposed to give us 112.5. It shifted inside. Okay. 112.5. Let's say 225. This is what happens. Okay, does not work. All right. $57.5. Goes up. 2.5. 5. It's not work. So it's very, very important to I'll get that before I leave here. Okay, I'll get that. All right, now let's see this one. Remember this, I'll get it to you. Now you come here, we are moving this outside, we are moving it this way by 450. Let's see, 450. We centralize it, we update it. Okay, I want you to project project 412.5. See it? It has come normal. All right. Now this one. Let's go. Let's go about it again. Let's make it 112.5. Let's see what happens. Wonderful. You see it? So assuming you have a column here projecting this way, mostly in schools and churches, so you have to put another column here, change the 224 to 450 by this, so that when you project it, it now project up. That is for columns. Is that all right? Now we have been able to do this side, do this side, do this side. Now let's go and do down, so that it can be complete. You highlight it, you go to this place, let's make it 450 by 225. No, 225 by 450. Yes. How do we move it to come up? come down? How do we move it to come down? You just go here, come to E2, make it 337.5, and it's just simple. Take note of it. So we have been able to do this side, do this side, do upwards, do downwards. That's okay. All right, that is on that area. Now what? Okay, that's what another one I will show you, but I need to put the beam so that you can understand. When you have a 150 beam and 225, now you have 150 beam here, you have 225 here. When you put your column here, it's going to be more than, because this is 2 to 150, it's going to be more than by 25 or 75. 150, 225 minus 150, the remaining one we project outside here. How do you move that projection to rhyme or to align with the 150, thereby changing the eccentricity? Let me put beams, then I will go into that. But another thing, how do we put round columns? Okay, let me put a round column now. Round column, I pick column here. I'll make everything to be 300. Okay, let's assume my diameter is 300. Just put 300 here. Just come here, see it. Very, very simple to put round column. Diameter, any diameter you want to put, that is how you put it. Anywhere you are putting it, just put 300. Just put, okay. That is for round column, okay. Circular column. That is how you put circular columns. Alright. Alright, let's continue. Now we're going into beams. We're going into beams now to insert our beams. Now there are a lot of settings that you need to do to help your work. How your work will look like is determined by you. Is that okay? Now, first and foremost, go to settings, set all your beams, set all these things. Column, just you have put columns already, just click on column, set it, take time. This is design. Come to steel bars, say bar spacing maximization method. Yes, leave it like that. Take time to go through it. Let all these things be there. That's kind of wall you are going to be designing. Find out that there is need for these double links, there is need for cross link. You can set it. So highlight all of them. You should be able to understand this as a civil engineer, how it works. This is detailing, you understand it better. If you are in the site, you should be able to interpret all these things for the iron fixers. Very, very important. We're not making use of wall in this context. We're not making use of this longitudinal bars. Go through, take time to go through it. Minimum bars and maximum bars. For this is talking about the same wall. So come to links. So maximum, minimum link, maximum link, minimum spacing in structural design. Minimum spacing for beams. To our maximum spacing should be 300. Don't go beyond 300 in your spacing. Don't go beyond 300. And minimum 100. Minimum 100. If you have any other alternative, maybe you feel that it's not true, you can decide to put anything. You are subject to look at it. You can change it. You can put it yourself. Alright. Then you go to the mesh. We are not making use of mesh here. So go through all these settings, you understand. You go to detailing, column bars, kicker 75. If you know what kicker means when you are casting your columns in the site, the mass concrete is not supposed to cover the column where you are coming out from the foundation. As you're casting your starter bars, your columns, it should be above the normal floor level by 75, so that mass concrete coming should not be able to breach the strength of that concrete. Is that okay? All right, you can change your layers, color, line, and all the rest. That is for column. That is for column. Now we are going into beams. You have to do settings on the beams. Beam settings, story beams specifically. So when you click on story, there are a lot of things you have to set here. Now in this, look at them, take time to go through all these settings. You remember that you're supposed to have knowledge of design for doing this. Right, parameters, your minimum bars and your maximum bars, top reinforcement, bottom spacing, and all the rest. Please go through them. Now, which type of pattern do you want your this to be? You can change the pattern of links. You can see the way the link is. You can decide to change it. You can change it to open. You can see how the links are now. You can change it to standard, which is this one. Is that all right? Now, when you come to method, this is the method. Come to still pattern. You do want your pattern to be like this in your steel arrangement in your beams. Now look at it. Now look at this is standard pattern 2. It has standard pattern 1. You're looking at your, see, it has changed. Your cranks has changed. Your crank has changed. This is 2. This is 1. See how it is? This is 2. This is 1. So I used to. Is that alright? Okay. I used to. You select how you want it to be like for you. Now use at least 2 bars in second layer. At least. If you don't want it to use 2 bars, I tell you to use the same bars you use face like second layer. It is going to put it like that for you. Anyhow you instruct it to do it, that is how it does it for you. You come to links, okay? Design link spacing at support. Same bars. Anyhow, if you want it to use the same bars, you want it to fix it, anyhow you want it, go through it and you will see maximum for double link 600. Okay, so go through them. Curtailment, the same thing. Talking about the lapping, talking about how you want the lap to be. Do you want it to lap inside the support? Do you want it to lap outside the support? Do you want it to lap like this? Do you want it to lap like this? You have the final say how you want the lapping to be. Okay, extend support bar symmetrically. See what is it? Just be watching, be looking here. Not too much cranking there. Support it bigger and leave it that way. Okay, come to your detailing. How will you want your detailing to be? What and what are you? He said it should detail with 1:20 so that it can be bigger. He said that it should match related objects, group related objects. You can say minimum wall length 1002. You can increase, you can, depending on how you want it to be. You're the one now specifying. Axis, show bar marks. These are the things you want it to be to bring out in your detailing. Show bar mark, display axis label, draw axis label, so on and so forth. You say both ways, both front and back. Is that all right? So layers, you can change your layers here. Now in Orion, if you go to settings, come to member and steel bar templates. If you open it, this place you can actually choose how you want your beam label to be. Now if you look at this place, it means that all this labeling will be inside the beam, and most people will always, when they finish, they will bring it out by themselves, one by one, wasting time. You can set it here. I want my beam label to be outside the beams. See it? See it? So this is beam. You're going to see the number here. Very, very simple. Beam dimension. Same, anyhow you want it to be. You are the one, you are in charge. Tell it what to do for you. Knowing fully well what you are doing, it will do it for you. That is why you are here. Okay, it's going to be showing this, meaning height, depth in your slab. Look at it. It will show you what the depth you use. This is how you're going to display it. It will write slab numbering here. It will write H150, H175, meaning the depth of your slab is 150 or 175, as the case may be. If you don't want it to use H as initial, you remove it, put what you want it to use. That's what it's going to display for you. Alright? Okay. Member label. Okay, look at it. Member label. If you don't want it to, it's going to be naming our beams. 1 beam 5. It means 1 means first story. Beam number 5. If you don't want it to name it like this, you can decide to change it. 1 point. If you don't want it, you can decide to change it. See, beam 1 5. It will be difficult for someone to understand this, you know. So you name it the way you want it to be. You see, you can name it only beam 5. Fine. You can name it beam 1. So it depends on you. Anyhow you choose it, let it be like that for you. You're the one giving it the instruction what to do. Alright, you come here. This is how it's going to be bringing out your detailing. If you don't want, this is going to be number of bars, bar mic, and spacing. If you don't want it to be like this in your slab, you can select how you want it to be. That means number of bars and the type and the grade of bar, the spacing, and this one. Why not make it to be normal? Okay, this is the pattern we use it in school those days when they are teaching us. Now this dot, this dash here, that is the separator. If you don't want it to be using this dash for your separator, if you want to draw 0 and let it be using 0 here for your separator, is your own. You are the one to decide it. Okay, all right. So after that, you just click on save. Then let's go and put our beams now. 225 by 450. Remember our insertion option. We select the same thing selected for our column. All right. Now, if I draw it and put it, it will number. Look at it outside. It's numbering outside. I can put here and decide not to put this side and come this side and put, and come back and put here. It will be numbering randomly. Are you getting me? But you can still make it. At the end of the day, you go and instruct it to number symmetrically. So it's going to arrange all the numbering for you. So don't bother too much how you number it. The major thing is to ensure that you insert your beams. Please, when you insert beam, ensure that the beam reach where it's supposed to reach. Sometimes you may be inserting beams. Let's assume that there is grid line that crosses here, and you just draw your beam from here, put here. You tell that the beam has entered. You don't know that it stopped at this grid line here. If you didn't observe it, you keep on putting slab here, it will not enter. You will not know the reason. So you better ensure that your beams get to where they ought to get to. Please. Very, very important. Put all your beams. Remember that is slab, that is, I normally chain my beams, chain my cantilever with slab. Okay, or I can remove it. That is not a big deal. I remove it when I get to up. When I get to up, I put it. So still on slab, still on beam, sorry. Put your beams. Now when you are giving a job to do, please you must take note of the sizes of, you see, it's asking me, do you want this beam to be considered as secondary and divide the format? It means that it's going to be divided. If I say no, let it be primary, this one will divide. If I say let it be secondary, it means this is the primary beam, this one is on top of this one. That is what it means. To be secondary beam, I say yes. See, it has divided here. If I say no, it will divide this one immediately. This one will go straight. That is what it was asking me. Okay. We are on modeling now. Now if you want to check if you have really done the work, see, this is 3D and plan. This is only 3D, this is only plan. This is 3D and plan. Click on it, allow it to come up so you can see what you have actually done. So you hold your right mouse down and rotate, rotate it anyhow you want. Hold your right mouse down, rotate it anyhow you want it. Rotate it, rotate it, rotate it. Okay. If you are satisfied, there is no stop, there is no one that stopped on the way. You know, check every of your detail. Okay. Then you can click back your plan. Alright. Now, because okay, I said something before. Now let me take this in back to 225. Okay. Since we have gotten what we are saying, 225 now. Now let's assume that this beam, let me make it 150, that this beam is 150 by 450. Now let's assume that this beam is like this. Look at where the beam is. So this one, please look at it very well. See the beam, see it, this one, see where my beam is, see where my beam is now. This one is the beam. Now it is here, and look at this, my column, this is 225, this is 150. Now look at the space the column is projecting outside. How do I bring the space of this column that project outside inside to align with this? To do that, click on your column. You want it to come down. Click on your column, go to your settings, put your E1 to be 150, put your E2, put your E1 to be 1125, put your E2 to be 150. Are you seeing it? It has aligned. It has flushed now. It has flushed with this beam, thereby more entering inside of this area. Please take note of it. Take note of this. Okay. I will be doing for this age also, for us to understand. Okay, now let's go. I want to push. Okay, let's make this beam 150 beam. Go to beam, make it 150. Update it. It's now 150. Okay, look at the beam now. Look at it here, 150 now. Okay, and this is 150. Now look at the difference of this column and this beam. I want to put this column inside to run with this beam. So we highlight this column, go to column settings, highlight the column, go to column settings. Put your E1 to 1125. Put your E2 to be 275. 275. Your E2, put it to be 75. 75. Did it align? Please take note. So many people will not teach you this. So many people don't know this. So many people will know it, they will not tell you. Take note of these things I'm telling you. Alright. That is for 150. We're trying to check columns that are 150. Let's assume that this is 150. Let's make this 150 so we can move this one also inside this way. Then we'll take this one as 150 and move this column inside this way. So we know that we have done for all the parts. Okay. Now this column, this beam, sorry, let's make it to be 150 beam. Let's make it to be 150 beam. Now you know that the column will no more be the same size. See the beam here now. See the way it's project. Now we are going to shift this column inside. We go to column. We want to shift the column inside. To go inside, you make your E to be 75. E1 to be 75 and just update. It has gone inside to align with that column now. Okay, let's do the same thing for this side. Make the beam to be 150 beam. If you are giving a wall that has a beam of 150, you must not do it like this. You set 150 beam before you put it so I can enter. I'm just doing this because I've already done this and I need to show you. We need to show you, that is why. Okay, now this column, look at it. Now look at this beam. Look at this column. You have to shift this column to align with this beam. Thereby, this side going inside more, defining the centricity here. So to do that, put your E. You just highlight it. Go to your column. Put your E1 to be 150. To be 150. Put your E2 to be 75. Then update. Say yes. Okay, what we have done here, I think you should do likewise. Put 112.5. Put 75. Okay. Let's settle the matter first. Now, take it this way. Highlight this column. We want to check what happened to this column. So 75 is going to be down for this other one. Okay. Alright. So let's go. Click it. 75. Sorry, I'm here to get it for you, okay? Just be patient. I need to get it. Just put this one 150. This is what happens. All right. Take note. Very, very, very important. You may not see anybody that will tell you this. You will not see it on YouTube. They will not put this kind of thing on YouTube. Is that all right? Okay. We have been able to treat columns that we know that will occur to us in the course of our design. Please take note. I'm putting back the things we are doing now to this normal shape of 225. So take note. So you write it down. You will need it. Put them back the way they were. I'll finish my illustration with them. So let's move forward now. Alright, we go to columns. Let's bring them back to 225 and 225. Let me bring excuse me, let me bring let's make this one the normal 225. You save. Always look at this. If it's not marked, always do that. It will save your last work. Okay, now we are going into our slab. We are not making use of wall in this our drawing. We are going to use this to generate our wall load, and that is all. We are seeing this work we are doing as a frame structure. Okay, so if I go to slab, so after column you go to bevel beam, you go to slab. But before you go to slab, I would like you to go to settings, go to slab design. Now this our drawing is a little bit different in a way that what is down is not what is up, and these patterns of arrangement is not too good. So as a structural engineer, you need to put those things into consideration. Now instead of making our this to be 250, we can say let our spacing be 200 because of the kind of arrangement we are having. You can make your spacing to be 150 here as well. So we say let our slab be at 150. Okay, now that is for slab settings. Steel bars, extend support symmetrically, long bar, put them. You now come here, make it 200. You now say view. Now say, just look at those things, go through them, put the ones you want, click OK. Alright, now we click on slab. When you click on slab, the minimum we can use is 150. The depth 150 and 25 as our concrete cover. Now when you have done that, this is under general. You come to load, you click on load. Now on load, our safe weight to be 3.6. 3.6. Now if you go through Onyonoga, when you are loading, on your loading, when you put all the partition wall, terrazzo, finishes to surface and this and that, you will arrive at something 5.8. 5.8. Now this 5.8 is unfactored. That is not yet multiplied with QK and QK, life load and dead load. Now when you multiply it, you will now get ultimate design load. Now we have not multiplied and you're having only safe weight to be this. Now what you have to make it up to be 5.8. So normally put extra dead load 2.2 here, but I can give you that 5.8. Now imposed load, we have different imposed load for different structures and the purposes. Imposed load for bank is different from imposed load for cinema houses. It's different from imposed load for machineries, equipment. It's different from imposed load of hospitals and all the rest. So imposed load differs. So for you not to be mistaken, domestic imposed load, for domestic building, for domestic use is 1.5. But put your cursor here, put your arrow here, just right click. It will bring all the whole imposed load so that you cannot make mistake. Go through them one by one so that you don't make mistake. So you will see machinery, kitchen, banking halls, for designing bank, factories, funding, shopping areas, churches, which is general assembly areas and all the rest. You will see all these things here. Toiletries, communal kitchens, bedrooms and hotels, bedrooms and dormitories, residential common areas and all the rest. So we will choose 1.5 because we're designing domestic building for domestic use. So I click here. Now once I've done that, I now took my cursor out inside. You can see it's highlighting this place to this place to this place. If I put it here, that is a panel. Where it has highlighted now is a panel for me. Beam region. That is beam region. Is that alright? Beam region. So I'm going to put beam here. Okay, that is beam region. Is giving us slab on beam region. Look at what I was telling you. Okay, if I click here, a slab, this is a panel. Now what he's saying is this is called yield line. Now if you want to analyze this beam, he said this is from here, this line come here, come here. This load will be counted by, will be catered for by this beam. This load here, all this load here will be catered for by this beam. Now if you know that this beam will carry this, all this load here and all this load here, so this beam is suffering more than this beam and this beam. because it has half of this area, and this area coming here. Take note, so many of us don't understand the pattern of load transfer. You know, in those days you will see our fathers and our mothers, when they are building, they will put big columns at the edges of the building. To them, those places are the places catering for the building, but they not know that internal columns are what is suffering. That is what is holding the house. And when they have already done all these things, before you know, you see different changes, tilting, you know, collapse and all the rest, because they don't understand load analysis. They don't understand. Now, this is one pattern, one way of putting slab. Now I will show you another pattern. Go to insertion. Now it's on beam region, that is why it's putting where there is beam region. Now go to, if you can put through axis region, beam region, pick axis, pick point. Now let's put on axis region. Now axis region, you can see, you see the axis. That's where I put it. You see the axis. From this is axis, this is axis, this is axis, this you now put it. You want to put it here. You see where you're putting it as axis. You see it's putting here because there is no axis that is countering it at the middle here. So it's putting, you want to put it. Do you understand? Okay. If I click it, you put it because there is no axis that is countering it. So you see from axis to axis to axis to axis. Take note. Now let me go to pick axis. Pick axis. Now in my pick axis, I will tell it the axis is going to put the beam. I want it to put in this place. Now I will pick this axis, pick this axis, pick this, pick this, pick this. Alright, watch now. Number 1, I pick this axis. Number 2, I pick this axis. Number 3, I pick this axis. Number 4, I pick this axis. I'll now return it back. If I want it to put here through this method, now watch. I'll pick this axis because this axis is the axis that crosses here. I'll pick this axis as number 1. This axis also crosses it. I'll pick this axis as number 2. Another axis crosses here. I'll pick this axis as number 3. There is axis here also that truncate it. I'll pick this axis as number 4. I'll go back and pick the first axis I picked before to insert. You want to pick points. Pick points. As I pick points. Number 1, I'll pick the first point. I'll pick the second point. I'll pick the third point. 1, 2, let's pick here. Let's see how this was. Pick points. It's not actually working now. Most times it gives me problem. I don't really know why, but that is another pattern of putting beam. Okay, you can see it's not coming out. So most times I don't really know why it gives me such things. 2, 3, 4, close it up. See, so most times it gives me problem, though I don't normally use it. 1, 2, 3, 4. It's supposed to insert now. It didn't insert. So we get again. 1, 2, 3, 4. It's still inserting on this one. It's still on big point. Okay. Still a big point. 1, 2, 3, 4. So each count 5. It's supposed to insert, but most times you don't know why it doesn't insert like that for me. Okay, so these are the patterns of inserting these slabs. Okay, so you try it out to your own. It will work, so try it out. So I've taken it back to being region and I'm inserting it. Is that all right? Okay. Now you save it. You save it. Save it. So this is the first phase of modeling. Let's check. This is the first phase of our modeling. You can see how it is now. See how it is. Is that alright? Okay. This is the first phase of our modeling. We'll be going through the next phase of our modeling in our next video. Hi guys, we have come to the end of the class on how to import your drawings, insert columns, insert beams, and insert slabs in a building. If you have found value in our video, please click on the like button, subscribe to our channel, and don't forget to turn on your notification bell to all so that you'll be notified when we drop a new video. If you missed our last video, please look at the top right corner of the screen to click and watch so you'll be on the same page. See you in the next class. Bye bye.